So now we will start the chapter projectile motion. So what is a projectile motion? Projectile motion refers to the motion of an object projected into the air at some angle. The important thing here is velocity of projection, that is the velocity with which the object is projected into the air, and the angle of projection, that is the angle which the velocity vectors make with the horizontal. So let's see this with the help of an animation. So here, as you can see, this is our projectile, which was thrown into the air with velocity u. So this is our velocity of projection. And the angle of projection is theta. So this is the angle which velocity vectors makes with the horizontal. So here we can see that we can resolve this velocity vector into two components, one along the horizontal, which will denote by ux. So ux will be equal to u cos theta, and uy will be equal to u sin theta. Now let's try to find out the equation of the path of projectile. So as we have seen, the velocity of projectile can be resolved in two components along horizontal and vertical direction. So the component of velocity in the horizontal direction is ux, which is equal to u cos theta, and in the vertical direction it's uy, which is equal to u sin theta. Now let's see what acceleration is acting upon this projectile. So there is only one acceleration, which is gravitational acceleration, that is g, which is acting upon the projectile, and it is in the negative y direction. So the acceleration in the x direction is 0, and in the acceleration along vertical direction is minus g. So in time t, projectile will travel a distance x along the horizontal direction, and which will be given by ut cos theta, where t is equal to time. Similarly, in the vertical direction, the distance traveled in time t will be given by u is equal to ut sin theta minus half gt square. So these are the two equations, equation 1 and equation 2. Now from equation 1 we can write t is equal to x by u cos theta, and we can put this value of t in equation 2. So we can write y is equal to u sin theta into t minus half gt square. We can put the value of t as u cos x by u cos theta, so y will be equal to u sin theta into x by u cos theta minus half g x by u cos theta whole square. So finally we get the following equation: y is equal to x tan theta minus half g by u square sec square theta into x square. And this is the equation of a parabola. So the path of the projectile is a parabola. We have denoted the equation of the path as equation 3. Now equation 3 can also be represented as y is equal to bx plus cx square, where b is equal to tan theta and c is equal to g by 2e square sec square theta. So this is another way of representing the equation of the path of a projectile. Now let's calculate the time of flight of projectile. Once projected, the projectile will come back on the surface after t seconds, where t is the total time of flight. So let's calculate this time of flight. As we can see from here, after time t, which is time of flight, the projectile is once again on the ground. So to calculate this time of flight, we'll make use of the following formula. We know that the displacement along y direction, that is along vertical direction, is given as ut sine theta minus half gt square. Now as you can see, the displacement along y direction will be 0 at time t is equal to 0, because if you put t is equal to 0 in this formula, you will get y is equal to u sine theta into 0 minus half g into 0 square, which is equal to 0. So at time t is equal to 0, the displacement along y direction is 0, which can be seen from here. At time t is equal to 0, the projectile is here. This is our projectile. At t is equal to 0. Also y will be 0 once again when the projectile touches the ground. So if you put y is equal to 0 in this equation, we'll get 0 is equal to ut sine theta minus half gt square, or ut sine theta is equal to half gt square, or t is equal to 2u sine theta by g. So after this time, that is 2u sine theta by g, the displacement along y direction is again 0. So this is our time of flight, that is t is equal to 2u sine theta by g. Now let's calculate the range of the projectile. Range of the projectile is defined as the horizontal displacement after the end of the flight. So to calculate this, let's see the animation again. So as you can see from here, let's say that projectile starts at point P, which is the origin, and after the end of the flight it is at point Q. So this PQ would be the range of the projectile. So in order to calculate the range of the projectile, we need to find out the horizontal displacement in time t. So to find that displacement, that is x, we need the velocity in horizontal direction, which is u cos theta, and the time of flight, which is 2u sine theta by g. So the range will be 2u square sine theta cos theta by g. Now 2 sine theta cos theta is equal to sine 2 theta, so we have range is equal to u square sine 2 theta by g. So this is the horizontal displacement of the projectile at the end of the flight.